Alright guys, so we're going to start out with 5.3 today, talking about binomial random variables. So with this lesson, we're talking about the binomial setting overall, okay? The acronym we use for that is BINS, B-I-N-S, BINS. That's where you can see our B is talking about our success or fail. Then I, you're checking to make sure it's independent. N has a set number of trials. And S is the same probability for each trial, okay? So with all four of those met, then you have a binomial setting. With a binomial setting, then, all right, we're able to do this probability calculation right here, okay? Dealing with this probability, in which case, the probability of X equals K is equal to your combination times the probability, raise the power of your successes, right? The number of successes times 1 minus your p-value, so 1 minus your success overall, raise the power of your fails, right? So again, this is dealing with success right here, and then your failures are dealing with this guy, okay? It's dealing with your failures. Now again, those probabilities for that need to add up to equal 1. And then for this, for your k value right here, and then your n minus k value, those must equal the total. So the total value, so your n value over here, okay? I know it looks like a lot, don't let it confuse you. It looks like a lot, but it makes sense once you start playing with it a little bit, okay? In which case we're going to do that and show you some examples here on what to do with this. So let's look at the problem. So according to New Jersey Transit, the 8 a.m. weekday train from Princeton to New York City has a 90% chance of arriving on time on a randomly selected day. Suppose this claim is true. Now we're going to just choose 6 days at random, and we're going to let X equal the number of days on which the train arrives on time. So first off, we want to see why this is a binomial setting. In which case we're going to use our BINS. So B, as far as dealing with success and failures, right? So success is dealing with the simple fact of the train on time, right? So the train's on time. Now what would be our failure? Well, of course, failure. Train is late, right? So if we have a failure, the train is late. Train is late. So again, success, train on time, failure, train is late. Then we're going to look at I for our BINS. We're going to look at the I. I is determined if it's independent. And so in this case, it's saying 90% of the time arriving on time each day, right? So again, is it really going to affect if a train arrives on time today, whether or not it's going to arrive on time tomorrow, or next day, or anything else? No. So yes, these are independent. One day does not affect the rest. So one day does not affect the rest. Alright, one day doesn't affect the rest of them. So the next value we're looking at in our little acronym here is the N for the number of trials. We want a set number of trials. And do we have a set number of trials there? Well, if we look here, it said choose 6 days at random. So it just wants to look at 6 days. So yes, a set number of trials, our N is going to equal 6. And the last set up here is our S for having the same probability. Okay, so having the same probability, and we know that that is going to be accurate here in this setup because it says that train has a 90% chance of arriving on time at a randomly selected day. So it's always going to be a 90% probability. So that same probability is true for this. So probability equals 0.90. It's horrible 9. Let me make that a little bit better. There we go. So 90% probability, so 0.9. So again, this makes it to where it is a binomial setting. We are able to answer all of the letters for our acronym BINS, right? We have success and failure, they're independent, there's a set number of trials, and the same probability. So now let's say we had to calculate a value for this. So to use that nice equation that everybody just loves, let's say they want the probability of x equal 4. Okay, so the probability that a train will arrive on time for exactly 4 days. That's what we're referring to, right? So I just want to know the probability that the train will arrive on time for 4 days. So with that, we are going to take that equation that we looked at. So we had our combination, in which case the total number of days we have in this was 6, so that's going over here for our total. Now, with this one, for the number of successes that we want 4. So the combination out of 6 for our total number of sets with 4 successes. Okay? Then we're going to multiply this by our probability of success. Well, our probability of success is 0.9. So I'm going to put this in parentheses so it makes it a little bit more easier to read. So 0.9. And we're going to raise that to the value of the number of successes they want us to have. So they want us to have 4. So 0.9 is raised to a 4. And then we're going to multiply this by a probability of failure, right? So the probability of failure, you would simply take 1 minus 0.9. Most of you probably said, well, it's easy, Mr. Elliott, it's just 0.1. That's great. If you see that automatically, that math right there in your head, great. If not, don't be scared to just follow the actual formula and write it out. It's perfectly fine. So now, how many failures will we have? Again, these top 2 power numbers have to equal our total of 6. So if we have 4 days on time, we know we're going to have 2 days that are failures. So when we put this in the calculator, you should come out to get a value of 0.0984. Alright, put in the calculator 0.0984. Alright, so again, if you don't have a graphing calculator like a TI Inspire 84, whatever the case may be, you can only use the Desmos graphing calculator. It's free online. Again, it's desmos.com/calculator. And it'll probably pull you up to the site. It looks just like this. In the bottom left corner, click a little keypad here that we've talked about before. Then to find your combination, you simply hit Functions, and then under Stats, and then the NCR button. When you do that, then you just need to put the value separated by a comma. So we want 6 total, is this number of trials, comma, and then we want 4 successes. Okay, so we know we got that value. Then we simply want to multiply it times our value of 0.9, and that was raised to the power of, we had 4 successes. Okay, and then we're going to multiply this all by our 1 minus 0.9, and we're going to raise that to the power of 2. And as you can see, it's already given us a value there. And we're getting 0.0984. 2, I believe, is what I wrote out here, or just 0.0984 is all we got to put out. 4 decimal points is all right. So again, you can always use that calculator at that website there, Desmos calculator. Okay. So again, what this is saying is, if you choose 6 days at random, there is a 9.84% chance that the train would be on time exactly 4 days. Out of those 6 days, there is a 9.84% chance that 4 of those days that train will be exactly on time. Alright, so I wrote it out so you can see it. So if you choose 6 days at random, there is a 9.84% chance that the train would be on time exactly 4 days. So 4 out of the 6 days, there's a 9.84% chance it'd be on time. Alright, so the last thing we'll talk about here is that we made a histogram. Alright, I know y'all all great at histogram. We'll talk about histogram again and then the shape of it. So again, if we have this value here, and let's give us a little room here to draw this guy out. So to do this, you would need to actually do the probability for each one of those days. So you would need to do this calculation we just did, this calculation right here, to get the probability for each one of those days. So this is for day 4, but you got to do the probability for each one of those. So you have the probability of x at 1, probability for x at 2 days, and so forth. Alright, all these all the way to probability of x to 6. And if you do that in the calculator, I have a UTI has probably helped me out quite a bit. It gives you those values here. So it gives me the values here going forward, and I'll explain these and how to draw these out, but the probabilities are given right here. So again, if we went to this top value right here, oh goodness, sorry about that, this top value is for 6 days, alright, of success out of the 6 days. So with that, they gave me a probability of 53.1% chance of 6 out of the 6 days to be on time. And that's so forth. And then for 5 out of 6 days, there's a 35% chance. For 4, again, there's got a 9.84% chance. And then for 3 out of the 6 days, it was a 1.46% chance. And then it got really small. Then we went up to having just 2 days of success. Then it got really low, right? Because there's a 9% chance to arrive on time. So for only 2 days out of the 6 to be on time, that'd be kind of very rare, because there is a 0.1% probability that would happen. So that should make a little bit of sense, right? The train saying it's going to arrive 90% of the time on time. So with that, it wouldn't make sense if that was a big number as far as your probability of only getting 2 out of the 6 days. It looks very promising for 6 out of the 6 days, 53% of the time, that's going to happen. So let's make a histogram and see how this would look using that data there. So if we're going to make a histogram out of this using those values, again, you have to just use a calculator to calculate those values up. Try your x and y axis here. Again, this is your x, the number of days on time, or just number of days, I should say. And then on our y-axis, number of days on time for x. Our y-axis is dealing with a probability. Now, with our probability, as you can see, the highest probability of 6 out of 6 days arriving on time 6 times was 0.53. So I'm going to say our highest probability is going to go up to 0.6. So we're going to say 0.1, so in other words 10%, 0.2, 0.3, 0.4, 5, and then 0.6. So that's going in percentages over there. Well, a decimal values, but looking at percentages, right? You're going to anywhere from 10 to 60% of the time. The number of days, we only did 6, so start out at 0, 1, all the way up to 6 here. Now again, it's a histogram, so all the bars should touch. And with this, these values are 0 going all the way up through, and I dealt with dealing almost with 2, I believe, even, right? So dealing with 2, it was down to 0. So at 3, I got up to 0.01, and then almost 1 at 4. So at 3, I'll say it's a little bitty line there. At 4, I got almost up to 1. So 0.09. For 5 on my calculator that I did, we got, when I had 5, so it was this second one right here. We had 0.35, so 0.35. And it kind of jumps up quite a bit there, right? So we're going to jump all the way up. 3.5. And then for 6 out of 6 days is 0.53, so come up to about right in here. Bring that over right there. Now again, we draw a histogram, we want to talk about the shape. So with this, our shape, hopefully you guys can see this is definitely looking like your left foot. You got your big toe over here and a little pinky toe over here at 0. So this is definitely skewed left. And it should be, right? Because it says we've got a 90% chance of arriving on time. So out of 6 days, we should have a high probability of all 6 of those, all 6 days out of 6 should arrive on time. So we have a 53% chance, or 53% probability of that happening, which makes sense. It's logical because it's a 90% chance of arriving on time according to the data of the train station. So hopefully that makes a little bit more sense and how that plays out. Again, don't let this big scary equation mess with you. It's not too bad. Just kind of got to think about it when you're writing it out, and also make sure your binomial settings work. To be able to use that formula, the bins has to check off. So you got a success or fail, I for independent, N for the set number of trials, and S for the same probability. So I hope you learned a little bit of something today, guys, and I'll see you next time.